Hello everyone, welcome to Data Avenue. In this video, I am going to talk about big data. Big data is a very vast area and it's a very important concept when it comes to data engineering. There are plenty of tools that are available in big data for data processing. So in this video, I'm not going to provide a very detailed training, but it's going to be an eye-opening session for those who want to understand what is big data and what is Hadoop, how the Hadoop ecosystem looks like, and how the data lake looks like. So let's get started. We live in a world full of data. In a single line, if I want to describe what is big data, so we need to understand this. We live in a world full of data, meaning that everyone in this world, either we produce a data or we consume a data. It could be anything, the social media, Facebook, using internet, YouTube videos, or accessing bank transactions, or any kind of transactions, the text, messaging, everything is a data. So the data, the word is very small, but it means a lot. So when it comes to the characteristics of data, it could be the volume, velocity, variety, and you can see so many V's, the characteristics of the data. The volume, the size, it's keep on increasing day by day. The velocity, the time takes to travel, and it's a variety. It's not a very structured, simple data is available today. So if you call any form of data in this world, it could be segregated into three types: structured data, semi-structured data, and unstructured data. So the structured data is the example of Oracle database, where you have a table where you have the stored in different columns: first name, last name, phone number, address. When it comes to semi-structured data, it is like example of a CSV file, XML file, JSON file. So when you move data from one system to other system, in order to communicate it, it generally used the different file system. So data is written in a specific format. For example, the CSV is delimited with comma, and XML is with the nodes, and similarly for the JSON. It's having its own structure, and it needs the customized code in order to create this file and also retrieve the data from these files. And the third one is the unstructured data, where there is no specific to the file or anything. For example, the semi-structure, at least you have the comma delimited. When it comes to unstructured, it could be, for example, the log file. There is no specific format, images, right? So there is no specific shape or size or anything. So those are called unstructured data. Let's understand the terminology, big data. A term used to describe a collection of data that is huge in volume. For example, Stock Exchange of New York generates about 1 TB of data per day, 1 terabyte. Before big data, there were plenty of tools available in the market. Any ETL tools or any query language, any object-oriented. There are many things that are there in the market. And it was very difficult to process this much of volume of data. So in order to overcome this, Apache came up with an idea called Hadoop. So what is Hadoop? Hadoop is a software framework. It's a collection of open source software utility, so that's using a network of many computers, right? It's in the distributed storage. So processing the data, the concept of MapReduce programming model. So when I say the network of many computers, it would be divided into two parts: the cluster of computers. The one is we need to process the data, and the second is we need to store the data. So how are we going to do this? Hadoop introduces, there are two components. One is HDFS, that's called Hadoop distributed file system. In Hadoop, everything is the file system. In order to storing it, either it could be, we are going to see the different types of files would be used. So when it writes into the system, it would be stored as a file. How it's going to process the data? There is a system called MapReduce programming. As name implies it here, map and reduce. Map is mapping a key value pair and then combine those keys, reduce it, and then bring the final output. It's all written in Java. That's called MapReduce. So let's look at how the cluster level MapReduce and the storage works. So let's look at the high level architecture of Hadoop here. So as I mentioned in the dotted line, the below part is the HDFS layer and above is the MapReduce layer. So the system is going to work here the concept of master and slave. So the master node is the one that's going to communicate with the slave nodes, get the job done. The MapReduce layer and the HDFS layer is not only divided into the master node, it's there in each and every slave nodes. For storage purpose, we have name node and also the data node. The data node would be available in slave and master, and the name node is available only in master. When it comes to MapReduce, it has two components. One is job tracker, other one is the task tracker. Task tracker runs in slave machine, job tracker runs in the master node. So as a developer, we won't have a directly access to each and every node. So we call it as an edge node, that is the master node. So we submit our job, the name node and the job tracker would be the primary contact for us, and they would get the job done using the cluster of computers. So when it comes to the storage, as I mentioned earlier, it's going to store it as a file system, right? Let's talk about an example. I have a file, so which is 513 MB of data. So when I store the data in file system, it's all stored in a small blocks. Each block is 128 MB of size. And the replica factor by default is 3. When I store anything, it would be stored in 3 different slave nodes, and the master node, it's having an internal algorithm to find out the nearest one and get the value from the slave node. Just in case, if one node is failed, then it will go to the backup and get the data from there. So here is an example. Let's talk about a 513 MB of file. In order to store that, the block size is 128 MB by default. It can be changed. It's all like more admin related activities. So in order to store this, I need to create 5 blocks. So 4 blocks of 128 MB, and the last block will have only 1 MB. So remaining 127 MB of data would be, it's a wastage of the data. It's a different concept altogether, how to improve the performance and how to write it very optimized way. It's altogether different concept. I'll try to publish one more video for it. So here is an example of how the MapReduce works. So you can find plenty of examples in the internet. So this is the example for word count. If you look at the input data, it's just a few words are there. Those are the inputs I'm considering for the MapReduce programming. As I said, the MapReduce is going to do 2 different jobs for us. One is mapper, second is reducer. And then we have the HDFS for storage. If you see an example here, from input to final result, first it's going to split the data. Line by line, it's going to split the data. And then it's going to map with the particular key. And then what would happen is, based on the key, it's going to shuffle the data into the different nodes. If you see the mapping and the shuffling, the same word is available in each node: car, beer, river. And then it's reducing it based on the key, the total number of count. Then it's producing the final result. It looks very simple because it's a very simple example. And the biggest disadvantage is, the first thing is, each and every operation here, splitting the data, mapping it, shuffling it, reducing, each and every step of operations, it will go and write the data into HDFS, retrieve it back, do it again, process it again, store it back to HDFS, bring it back to again. So this whole process of writing, reading, writing, it makes a lot of delay. When I say Hadoop ecosystem, it's not only HDFS, not only the MapReduce. On top of it, and today we have plenty of tools available. So in Big Data, you can see every day there are new tools are coming up. I'm not covering each and everything, but I'm trying to give up some kind of inputs on each and every tools here. So you can Google it and see, you can find it out, the different versions of Hadoop ecosystem. So I'm just taking one example for explaining each component here. Let's build the ecosystem here. Okay, what I'm going to do is, so whatever we have seen in the previous slide, we are going to quickly look into each and every component. What is it, and what is the purpose of using in Big Data world? So we already spoke about HDFS, we already spoke about MapReduce. In order to bring the data from outside world to HDFS, so we have a different tools that's called a data ingestion process. So we have a scoop. In order to bring the data in, we have to use the scoop import. So usually it helps to bring the structured data from Oracle kind of system to HDFS. And in order to bring the unstructured data, there is a tool called Flume. So that helps to bring the unstructured data. And when it comes to streaming data, that's called the real-time data. So there is a tool called Kafka. So that would help us to bring the data from the streaming, the topic. And the scoop export is used to get the data out of HDFS to any Oracle system, RDBMS system. So this is how initially the big data started. So first initially the HDFS was there, MapReduce was there, and then Yahoo came up with an idea, the scripting language, that's called PIC. So why? So why Yahoo came up with this idea? As I mentioned in my initial slide, the MapReduce, the HDFS, the processing and the storage part, right? The processing part of the MapReduce is written in Java. In order to use this HDFS, the big data concepts, a person should be aware of Java. Otherwise, it's very difficult to, convert the requirement, and then retrieving the data was very, very difficult. So when the big data came to the market, by the time many people started using the query languages and ETL kind of a tool, and it was very difficult for people to adopt the system. That's why Yahoo came up with the idea of overcome this issue. They introduced a new language called scripting language, that's called PIC. So that's still run on top of the MapReduce. Similarly, Facebook created the SQL kind of a language where I can go to the system and write a query, select star from table. So that's called the Apache Hive. It's similar to SQL. That is again run on top of the MapReduce. MapReduce will communicate to HDFS to get the data out of it. Since we have the multiple components, try to use the HDFS. So we want someone to control it, right? In a company, how we have different departments, we have a HR and resource managers who help us to manage the multiple teams. Similarly, here it's called YON, yet another resource negotiator. It's a resource managing tool for Hadoop. So what happens is when we have this kind of a big hive and multiple components want to interact with the HDFS, it helps a lot. So then if you look at this pig or hive, it was using MapReduce to access the data from HDFS. So the MapReduce is very slow because every part of its internal process, it's trying to write the data in HDFS and retrieve it, process it again. So even though there was a new set of languages from Yahoo and Facebook, the pig and hive, it was using MapReduce and it was very slow. It was very difficult to use for high volume of data. Then the Impala tool was introduced, which is very similar to Hive. As mentioned in this slide, it is not accessing via MapReduce. It is directly accessing the HDFS and get it. So how can I use this Impala? So it's having its own the query engine. There are two ways of using it. One is CLI, so where you have the command line interface. That is how if you want to communicate with HDFS, you can use the CLI, Impala CLIs from any external system in order to query the data. And also there is a UI, it's called Hue, Hadoop User Experience, so where you can go and type your query and get the data. So Impala also works in a very similar manner to Hive. It's having its own query engine, and then it maintains the metadata of tables similar to Hive. So then we have something called HBase. HBase is mostly used for the unstructured data. It's called NoSQL database. It's all stored in the key value pair. When I say NoSQL, it's not only SQL, right? So Hadoop can perform only batch processing and data would be accessed only in the sequential manner. It's predominantly used for storing the unstructured data, and in order to accessing it randomly, if we want to access it randomly, so we can use the HBase here. So there are plenty of other NoSQL databases there, Cassandra, Dynamo, MongoDB. These are the few examples. Let's understand what is Spark. So far we have seen Pig, Hive, Impala. These are the predominantly used for accessing data from HDFS. So now let's talk about Spark. Spark is to, I would say, it's a very high-speed data processing system, whereas MapReduce was a very bit slow. There are certain tasks is, I would say, 100 times faster than the MapReduce in some of the cases. It's again like an open source system, and how initially the MapReduce and HDFS was introduced as a cluster, it uses a similar one, but it's having its own architecture of core, and it's having the in-memory computation, giving different types of APIs like data frames, RDDs, and datasets. So where you can easily read the whole table as a data, and then store it within the memory, and it gives a lot of inbuilt functions, SQL, streaming, and machine language functionalities. And it always goes with a good combo with Java or Scala language, where you can write a lot of the data analytical related functionalities. We can make use of the inbuilt functions to increase the data processing. So that is significant using of Spark programming. In addition to this, we need to understand what is Uzi. Uzi is a scheduling tool. It's not only the Uzi is not only the scheduler. There are Airflow, Xena. There are a few others, and we have the web UI monitor in order to monitor at the cluster level, and then we have the Zookeeper. So this is for centralized service for providing the configuration informations, naming and synchronization purpose. So far we have seen what is big data ecosystem, MapReduce, and what are the different tools are used. So let's understand a little bit about HDFS. Earlier I mentioned we are going to use different file system to store the data in HDFS. Whatever we are going to store, everything is written in form of files. So here I listed totally 7 files. We can store the data of text, CSV, JSON, XML. JSON, XMLs we can store it, but we cannot read it directly as a select star from so and so. So it needs some kind of customization or code to retrieve the data. In Avro, sequence files, RC, ORC file, and Parquet. As I highlighted in the red color, which is commonly used for storing the data in data lakes. So I provided the tabular form here and the comparison between each file system, and also the same set of data, which is having here, I provided an example here, 585 GB of normal data when you want to store in text format. Same thing when I want to write it in the RC file, how the size is getting reduced. 505 GB will be used, which is a 14% smaller than the original size. When it comes to Parquet file, so which is 221 GB, which is a 62% of smaller size than the original one. And ORC is still more, gives the good compression one. And here the tabular form is talking about what are the different file formats and what are the different features it's available. Here, for example, the Parquet, ORC, and RC, those are stored in column-wise, whereas the rest of the things are stored in the row-wise, and it provides a different kind of compressions, snappy compressions, and in order to reduce the overall size. And it's all a few other characteristics, the schema evaluation and random access, whether it can be used via MapReduce or not. And here is a typical the data lake architecture. So we already spoke about the structured data, semi-structured data is unstructured data. As per this architecture, so what we do is we consider the whole HDFS as the data lake is divided into different layers. So this is just for our discussion purpose. I use this, but project to project, organization to organization, it varies. It's not only the 3 layers, it could be 3 or 4 layers and different names. So just for a discussion, I'm using this as the raw layer. Some places it could be used as a landing layer, and transform layer would call it as a refined and prod layer kind of. So the data, the structured, semi-structured, unstructured data can be stored as sources. And those data, we already seen different tools. Those tools can be used to bring the data to HDFS to the raw layer. For example, the structured data, we can use the scoop. Semi-structure, we can just use the file ingestion mechanism, or Kafka kind of tools can be used for the streaming data. So once the data comes to raw layer, it is as it is load, and then we can apply the business logics between the raw layer to transform layer. And finally, it would be stored in the third one, the refined layer here, where you can see the more curated data, where the duplicates are removed, more cleansing, everything is done. So that would be consumed by different consumers here. Data mart, machine language, or data visualization purpose, or analytical purpose. And the data governance would be applied all across the layers. So even though it's all called as a layer, technically, when you log into the system, you can see each and every layer is called a DB. They call it as a database, a raw database, transform database, and refined database. I used to get so many questions from my team members. So in order to come to become a data engineer, so where to start? So there are plenty of tools available in big data. So I work in the ETL technology. I work in different area. I want to learn big data. So which one I should learn? It's a very important question, right? So if you see here, we have the data architecture. So we have a different types of data. We need to bring it down to HDFS, that is called the data ingestion. I always say that the data ingestion is a very simple, or it's a right place to start, where you already know the ETL or similar to ETL. People worked in SQL, having a knowledge in SQL, it's easy for them to write the scoop query and file ingestion, scripting, anything. So that is a place where you can start, and then you can start learn about like a Hive and Spark and those technologies to become a master on this. So here is a list of tools and technologies that is required to become a complete data engineer. The scoop, import or export is commonly used for data ingestion purpose. Whoever wants to start your career, better to start in the data ingestion. It's easy to start with, and slowly you can learn other technologies. And Kafka is for the data streaming, and Unix is very, very important. The basic commands and scripting language, how to call the Hive, Beeline, or Impala, the CLI commands, or how to invoke the Spark Summit from the Unix. It's very, very important. And understanding of HDFS commands, how to use it from the Unix machine, how to place the file in HDFS, how to get it back to Unix machine, shortcuts. And Hive is very important. It plays a very important role for query the data. And Spark, of course, for data processing. And SQL is for Hive and Impala. In addition to all this, we should aware of what are the Bitbucket, version control tool, and any code migration tool, Jenkins. The Bitbucket is usually used for storing the configurations under code, and then Jenkins is used for migrating the whole build from Bitbucket to our dev system or QA or prod, and Airflow or Whoozy or Xena kind of a scheduler. So these are very, very important areas. If you want to become a full data engineer, so these are the tools we must aware of it. So that's the end of this session, and thank you for watching. If you have any questions or comments, you can write it below, and I'll try to publish more videos in data engineering and in terms of detailed training. Thank you so much.